thinking about it. Well, hello, everybody. We're live on the .NET Foundation YouTube for their virtual user group. And I'm from South Florida, and Sam here is from the UK. And this is part of the Microsoft Cloud South Florida user group presentation. And we're also, today we're doing it via the live stream that .NET Foundation supplies. So I'm also a volunteer with the .NET Foundation. And if you get a chance, you can go over there and check it out. There's a speaker area now where you can submit yourself as a speaker. And hold on, I got some feedback here. And you can also get support for your meetup. If you have a meetup, you can get the free meetup hosting. And then you can also request support to have, live stream support and demand generation for your user group. So anyway, with that, I'm going to let Sam take it from here. And thanks for coming.
No problem. Well, good evening, everyone. As mentioned, my name's Sam. I'm Sam Cogan. I'm a Microsoft MVP from the UK, and I work as a solutions architect for a company called Willis Towers Watson. And I spend my day working with Microsoft Azure, and in particular, I spend a lot of time working with infrastructure as code and deploying resources into the cloud. And so today, we're going to have a session that looks at what infrastructure as code is and gives a bit of an introduction as to why this is something you might be interested in and how to get started. Yes, as I mentioned, I'm based in the UK, and I do a lot of community stuff around Microsoft Azure and other things. You'll find there's a lot of information I put on my blog at samcogan.com if you're interested. And if you want any of the slides or the code samples from today's session, you'll find them on GitHub as well at github.com/sam-cogan. So you can see them all there, and I'll provide those links on Twitter as well afterwards if you're interested. So we're going to start off, first of all, looking at what is infrastructure as code, what it's all about, and why it's something you might be interested in having to pick up. So if you look at the sort of the definition of it, it's what it says here. It's provisioning resources using machine-readable definitions. Okay, but what does that actually mean? And in particular, what do we mean when we talk about modern infrastructure as code? Because in reality, any sort of provisioning of infrastructure using code of some sort could be considered infrastructure as code. So writing bash scripts, writing some PowerShell and those sort of things could be considered as a way of defining your infrastructure as code. But there's quite a specific meaning when we talk about this today. And in particular, when we talk about it with relation to the cloud. So cloud services is really where infrastructure as code sort of became a mainstream thing, because now you're no longer sort of building physical hardware in data centers and having manually configuring it or using bash scripts and so on to actually set things up. You've got access to this whole cloud world where you can create resources on demand. You can spin them up and tear them down as you need them. And so this has led to sort of the spread of infrastructure as code and infrastructure as code tools to allow you to define what your cloud infrastructure looks like in a code-based fashion, rather than manually going into one of the cloud providers' portals and clicking on a few buttons and getting some resources. I mean, that's fine. You can certainly do that, but it's not really scalable, and it's not something you want to be doing to get repeatable infrastructure. And so as we move into that cloud world, and in particular, as more developers make use of these cloud environments, it's no longer the IT ops teams who are actually managing a lot of these resources. Developers are building them themselves. We're moving to this DevOps mindset. Infrastructure as code is something that's being more and more prevalent, particularly in the development world. So when we talk about infrastructure as code, particularly in the modern usage, there are a few traits that we've got here that really sort of document what an infrastructure as code language or tool would provide. And the first thing, and probably the most common trait between any of the tools we're going to look at, is that they're declarative. So this really sort of removes the bash scripts and the PowerShell scripts and so on, where you're writing imperative code that goes one line after another. what you're doing with most infrastructure as code tools is you're declaring what you want to see, what you want to be deployed, and caring less about how it gets deployed. So you're saying, I want 3 virtual machines and some storage accounts, and I want them in this region, and I want them configured this way. Give me those. You're not worrying about how you actually tell the cloud platform to get them. You're not necessarily worrying about handling errors. You're just declaring what you want and assuming that it will be taken care of for you. In combination with that, they are generally idempotent, so that if you run the same piece of infrastructure as code more than once, it will give you the same result. It won't do something different the next time you run it, even if the resources already exist. Whereas, if you're running a PowerShell script, for example, and you ran a create command and the resource was already there, it'd probably give you an error. Whereas generally a declarative infrastructure as code tool would recognize that and would deal with it and would give you the same result at the end. So the infrastructure would be in the same state. Generally, they're immutable, or at least that's the design idea behind them. It's not always the reality, but in this case, this is the case that if you deploy a virtual machine and it's working, and then you want to make some changes, you can go down the route of actually changing that VM itself, but you could also just destroy that VM and create another one. A lot of the language will offer immutability, but don't necessarily enforce it, and we'll see that later. So you can choose whether you follow that route, but it is something you can make use of. Reusability is quite a big thing. So you want to be able to take your code that you write as infrastructure as code and use it more than once, just like you would with some classes you write in your actual programs. You want to be able to make them generic and then pass in some parameters and reuse them to create your development environment and your test environment and your production environment. You don't want to have to write unique code every time. And in combination with that, ideally, you can make them modular. So not only are they reusable, but you can package up into useful modules your infrastructure as code and pass them around your teams, share them with the community, those sort of things. So maybe you've written a really good piece of infrastructure as code that will deploy a virtual machine configured in a certain way, ready for use by a certain team. And you want to be able to pass that to that team and they can use it, but you'll still manage it. You can create reusable modules. And then lastly, due to the sort of the declarative and the idempotent approach here, we get sort of built in the ability for drift correction. So if all of our infrastructure is actually declared in the code file, then that is effectively our desired state. So if we then rerun that piece of code against an environment that maybe somebody's gone in and manually tweaked and we didn't want them to, then it should reset that environment back to how we define things in our code file. And so it should give us that drift correction if we want it to be able to ensure that what we've written in our code matches what's deployed in our cloud provider. So that's how we would generally define a modern infrastructure as code solution. So why would you want to use it? Why bother moving away from manually deploying things using the portal or writing a bit of PowerShell and so on? Again, we've got some tenets here. The top one on the list there is about consistency. So if you're deploying things manually using the portals, then you aren't necessarily going to get things working or get things configured the same every time that you create them. And in fact, more likely than not, you're going to have something slightly different every time you deploy a resource. And so if you're going to declare that in your infrastructure as code file instead, and just rerun that when you want to create, more virtual machines or so on, you can pretty much guarantee that your virtual machines should look the same every time you do a deployment. We're also going to talk about speed. So if you're looking to deploy resources in the cloud, and in particular, if you're looking to sort of deploy resources on demand, you want to be able to scale up and scale down and create new resources quickly. You don't want to have to wait for some complex scripts to run or for somebody to manually go in and press all the buttons and realize they've changed, set something wrong and go back and so on. So infrastructure as code, because you've already defined what you want things to look like, the actual deployment time is going to be fairly minimal because it's just running your code. There should be no interaction required. You should be able to just run your code and get your resources out the other end pretty quickly. It's very rare that you're actually going to be building whole environments of code by yourself, unless you're working in a very small environment. So often you're going to be collaborating with other teams or with other people on your team. Maybe you've got a networking team that deals with how you build your actual networking infrastructure, and then you want to layer on some application infrastructure and so on. And so by having all your code files or having your infrastructure in code, you can collaborate on those files just like you would any other piece of code. So you can put them in a version control repository. You can share them between teams. You can have code reviews. You can have pull request policies and so on. You can work as a collaborative team, creating those resources and sharing resources between the teams as much as you need, because it's just code at the end of the day. Similarly, because it's code, you can also use it as a sort of an accountability and change management tooling. So if you're going to put these things into Git, you can see who's made changes. You can see what the difference is between what you're trying to deploy today and what was deployed last week, and you can see what changes are being made. And we'll see some demos of that in a minute. So you can actually keep track of what you're doing with your infrastructure and see its progression over time. Scaling, as I mentioned, is something you're probably going to want to do in a cloud environment. You're going to want to scale up and scale down environments. You potentially want to deploy lots of environments. You want to create test environments that you create ad hoc and then tear them down again. If you've manually got to go in and create more virtual machines and do that, that's not sustainable. Whereas with a properly created infrastructure as code, the amount of virtual machines you've got running could be as simple as changing a parameter from 1 to 2 or whatever. And deploying a test environment could be as simple as just creating some extra parameter files and running them. So very quickly we can scale up the amount of resources we need and scale down again when we're done because of this. We talked a bit already about change control, and alongside that we've got versioning, so we can version the files either manually or we can put them in a version control system and keep track of that. And also, again, because this is just code we're writing, we can test it. And I'll show you some demos in a bit about how we can test your infrastructure as code files. And then finally, your infrastructure as code becomes part of your documentation. So now if you want to know, what does this environment look like? What resources are in it? How are they configured? It's already documented in your version control system, and you see who actually made the changes, and you can read that as part of your documentation to determine what's being deployed. So now we have a set of resources that allow us to deploy resources very quickly, very efficiently, and with a lot of governance and change control around that, which is much better than, again, somebody manually going in and clicking some buttons and then forgetting what they did when they come back to it a month later. So we're going to delve into some of the tools and how some of the infrastructure as code works now. But before we do that, I just want to bring up one thing here, which is the fact that we're looking here at infrastructure as code. And there is a difference between infrastructure as code and configuration management as code. And they are two sort of different sets of tools. We're talking about writing infrastructure as code, which deploys actual resources. So virtual machines, storage accounts, web applications, all those sort of things. Whereas configuration management usually refers to actually how do you configure resources once they've been deployed. And in particular, how do you configure virtual machines once they've been deployed, which is what a lot of these tools look at. So things like Puppet, Chef, Ansible, and Salt are tools that deal with configuration management. And we're not really going to dive into those today. They are usually something that goes hand in hand with infrastructure as code. So usually you'd use some of these infrastructure as code tools to actually deploy some virtual machines. And then when you're done, you would trigger your Puppet or your Chef system or whatever to then go and configure that virtual machine, usually by passing it some details about how to register with your Puppet server or your Chef master or whatever. And it would then take over from the infrastructure as code once it's finished. But there is very much a difference between those two tools and what they're trying to achieve. So we're going to look at two different classes of infrastructure as code toolings. And we've broken them down into those that are provided by the cloud vendors themselves. So each of the big cloud providers has their own set of infrastructure as code tooling you can use with their cloud. And then we're going to look at some third-party tools as well that are sort of vendor agnostic, and we'll see what the difference is and when you'd like to use one. Also, if at any point anyone's got any questions or anything they want me to reiterate, please just put it in the chat. I'll be more than happy to pick that up. Okay, so we're going to have a look first at these cloud vendor toolings. So we're going to concentrate on the three big cloud providers, so AWS, Azure, and GCP. Obviously, there are other cloud providers who may have their own tooling as well, and they're probably along similar lines, but we'll focus on these three. And so if you look at those providers, they've each got their own sort of native infrastructure as code tool set that they've developed. AWS has got CloudFormation, Azure's got ARM templates, and GCP's got Deployment Manager. And they are, whilst being different, they all have fairly similar traits. So they are direct from the cloud provider. They are supported by that cloud provider. So if you're using their tooling and you have problems with it, they will generally be able to help you with those issues. And they are most of the time going to get updates the fastest. So if the cloud provider releases a new service or changes an existing service, this is going to be reflected in the cloud provider's native tooling, probably before some of the third-party tooling that we'll talk about in a minute. These cloud provider tools are also stateless. And so it's worth taking a minute just to understand what I mean by stateless. So when you deploy resources into the cloud provider, you're creating those resources actually in the cloud. And some of the tooling, particularly when we look at the third-party ones, will actually record what you're doing in what they call the state. And so this allows them to have sort of a history of what you've done, have a way of keeping track of what's been created, what's been destroyed, and so on. And yeah, that's usually something you have to manage separate to your cloud provider. So these cloud provider tooling, native tooling, are not state-based. So they effectively use the actual state of resources in the cloud as their state. They don't have a separate state file, which has some benefits because you don't have to manage that state file. It's not something you have to care about and look after, which can be quite painful. But you'll note that we've also put it in the negative column because there are some benefits to having a state file that we'll talk about and we'll see demoed in a minute. But the state file can provide you useful tools such as being able to do plans and destruction of resources. Other things in the negative column, obviously, each of these tools is for a specific cloud. They don't work with, you can't use CloudFormation to deploy things into Azure or anything like that. There's no collaboration between the cloud providers. So you are limited to using a single cloud. They're also closed source, so none of the cloud providers actually release the source code for any of these tools. They are not available on GitHub or anything like that. So if you need to be happy with the fact that you aren't going to be able to get access to the source code.
Sam, we want to take a couple questions.
Yep. I was just going to stop here, so we'll have a look first. So, Chad, you mentioned blueprints seem to be missing on the last slide. So we talk about, I assume, this summary slide here, and you talk about Azure blueprints. Assuming you are talking about Azure blueprints, then yeah, they are. I'm not sure I would bundle them into the infrastructure as code bracket. They are a sort of a higher level abstraction, which can include infrastructure as code. So you can use ARM templates with blueprints, but blueprints are doing a bit more than that in the terms that they work with policy and governance as well. But yes, they're not on this slide, and perhaps they could have been. And then Pravi asks, how are logs analyzed for silent, non-ideal states? So I guess I'm not entirely sure what you're asking on this question. So, I mean, the states usually, if you're talking about using a state file, they usually obviously reflect what you've done. Now, you can get state files into a bit of a bad place if you try hard enough. It's possible to have errors and so on that actually cause issues with state, which is one of the disadvantages of having to manage a state file. And the tools that use state do provide some facilities to go in and help you clean up those state files if you do get into a bad state. But to be honest, it's not a great place to be if you have managed to get your state file somewhere where it's where there are problems. You can also back up those state files, obviously, so you can get back to a state that way.
I think that's it.
Okay, so we're going to have a quick look at a demo now. So we're going to have a look at the sort of the cloud native ones, and we're going to focus looking at the Azure tooling, just because I'm most familiar with that one, and have a look at ARM templates. So ARM templates, or Azure Resource Manager templates, if you want to take the full name, are a way you can define Azure resources as code, and they use a language that's basically written in JSON. And you define your resources as basically big lumps of JSON. We've got a template file here, and this is a very simple template. So what we're trying to do here is deploy a storage account. That's all. So we've got this file. You can configure your templates to actually receive parameters. So we're passing in a parameter here called storage account name, which just allows us to vary the actual name of the storage account. So we could reuse this template to deploy, any number of storage accounts we wanted to, just by passing in a different name. And then we've got another parameter here called storage account SKU, which is the actual type of storage account we've got. And we can do things with this parameter like defining a list of allowed values. So we can say, you can only specify these 3 strings and nothing else, and it'll error if you don't get that. We've got some variables that allow us to define sort of properties that are, they're not passed in as parameters, but we can set them inside the template and then use them throughout the template if we want to. So we're using the actual API version here set as a variable. And then we've got the actual resources themselves. So this is where we are actually creating the storage account. And this uses a syntax that's defined by Microsoft. And there are a couple of things you'll have on every resource. So every resource is going to have a name, and we're just passing in from that parameter. So this uses a sort of function language that Microsoft have created here, which you can define. I want to use that parameter. Then we've got the type of resource, and this uses a naming convention again that Microsoft has set, which is in this case Microsoft.storage/storage accounts, and then an API version. So each resource in Azure will have an API effectively that you can use to create from, and that changes over time. So you can define the version of that API you want. We're defining some tags. We define the location that the resource gets deployed to. And you can see here, I'm not actually putting a real location in. What I've used is there are some built-in functions you can use, a sort of mini programming language to actually define certain things. In this case, there's a resource group function, which gets me information about the current resource group I'm deploying to. And if you're not familiar with Azure, a resource group is basically just a bucket where you put your resources. It's a folder if you want. So I can get the information about the resource group I'm deploying into, and I can just grab its location. So everything that's going into that resource group I'm deploying is going into that location. Then a kind, which is these bit parts here. So the kind and the SKU are just properties that are defined that are specific to a storage account. So a storage account has these values. A web application will have different properties that are specific to a web application. So in this case, it needs a kind. There are 2 different types of storage accounts. We're using the V2 one. And then we need to pass in the SKU, which again is coming from a parameter. And there's a tier. So there is a standard and a premium tier for storage. And we're using the standard tier. So we can define any number of resources in this resource section. We can add dependencies if we wanted to. We can build up, quite a big file here if you wanted to actually create resources. You can also have multiple files and call one file from another, and so on. So it is it's a fairly complex set of tooling. The JSON language is, you talk to most people, is quite verbose, and there is efforts going on at Microsoft at the minute to make that a bit less verbose with a new language that sits on top of ARM templates called Bicep, which I'm not going to dig into too much here, but it's a way of writing your ARM templates without so much of this JSON, which is interesting. But I can use that to define my resources, and then I've got a parameter file here, which is where I'm defining some of the values I'm passing into the template when I want to deploy it. I'm passing in just a name here. You could have multiple parameters files. So maybe I had a development parameters file and a production parameter file and so on. At the time I come to deploy the resources, I would tell it, which parameters file I want to use, and it will pass that in. So to actually deploy the resources, we need to be in the right folder. You can see here, let me zoom in a little bit. We've got those two files. So to actually deploy ARM templates, you need to either use PowerShell or CLI to basically trigger the template. You can also pass it to a REST API. But we're going to use PowerShell, so we're going to do the new AD group deployment. And so, as I mentioned, we're deploying into a resource group, which is just a holder for the resources. We need a name for the deployment, so we'll just call it demo. We need a resource group name. So I think I've got one configured here. Yeah, so we've got an ARM demos resource group. This is the Azure portal if you've not seen it before. And this is just a resource group I've created, which is empty currently. And then we're going to pass it the actual template file that we want. And we're going to pass it the template parameter file that we want as well. So you could see we could vary that parameter file based on which environment we were deploying or whatever. So we'll go ahead and run that. And it apparently doesn't like the template. It did work earlier. Okay, it doesn't like the name because apparently I've used that before. So that's a very simple fix. So we'll just go in here and change the parameter file. And we'll run that again. And that will go off and talk to Azure and actually deploy the resources. And you can see obviously from this particular error that it does some checks before it actually runs the template. In this case, it checks for the validation of the storage account name, which needs to be unique. And that's why that failed. But that's going to go and run now. And that will take a little while. I mean, the storage accounts don't actually take too long to deploy, but obviously you are waiting for resources to be allocated and so on. So, okay, there we go. It's just finished. So that gives me some output in terms of it'll tell me the storage account name and type that I've actually created. I could grab those outputs and use them in some scripts or whatever I wanted to do. So that's an example of what a sort of cloud native or a cloud provider native tooling looks like. That's the Azure one. If you look at CloudFormation in AWS, it's not too dissimilar. It doesn't use JSON, but it's not overly different. The GCP one I'm not particularly familiar with, but I imagine they're of a similar vein. But there are also some third-party providers that provide tooling to do infrastructure as code as well. And the two we're going to talk about today are probably the most prominent ones, which are Terraform and Palumi. And Terraform is probably the one you've heard of if you've heard of any of them. So these tools allow you to create, again, infrastructure as code. But because they're third party, they generally, both of these are cloud agnostic. So they have the ability to create resources in all of the major cloud providers. They also have the ability to look at other resources as well that aren't specifically cloud providers. So you can use them to create resources in AWS, GCP, Azure, but also things like DNS providers. You can even use them to deploy things, some things on-prem as well. They have a lot of what they call providers available. Most of them have, they both have 50 plus providers that you can actually use your infrastructure as code. So if you're looking to do either multi-cloud or looking to deploy alongside other resources, they can be a very useful tool. One of the most common reasons you might use them is if you're looking at using cloud providers plus Kubernetes. So if you're let's say you're hosting your Kubernetes cluster in a cloud provider, but you also want to write infrastructure as code that then deploys your applications on top of your Kubernetes cluster, then, and if you look at the cloud native providers, they don't deal with that. They mainly they'll deploy the Kubernetes cluster for you, but they won't deal with anything on top of that. Whereas something like Terraform or Paloma, you can use the same language to create resources inside that Kubernetes cluster that you just deployed. That's a fairly common approach. So they can support multi-cloud, they support non-cloud resources. Both of these languages are stateful. So they have state files that you need to manage. State files will need somewhere to live. If you're doing development just by yourself, you can store your state file on your PC, but that doesn't scale beyond one person, and it's not very secure. So you can put them in other places. So you can put them in S3 buckets, you can put them in Azure storage, but you've got to manage that. You've got to make sure it's secure and backed up and so on. But because they are stateful, because they know what you've deployed, they offer some additional features. So they allow you to do plans, which you can have it tell you what it's going to do before it does it. So when you come to deploy some resources, you can find out, that it's actually, okay, I'm going to go create a storage account. I'm going to amend this web application, and I'm going to delete this function application. You can get that information before you've actually done it to make sure that it is what you wanted to do. They also offer some abilities around destruction. So when you're done with some resources and you want to get rid of them, if you're looking at the cloud provider native tooling, you will generally need to go in and delete those manually, or delete the container they're in, like the resource group in terms of Azure. Whereas because these tools know what they've created, they also know that they can destroy it. So you can run a single command and it will delete everything that you created with the infrastructure as code, which is a really nice tool if you want to be able to clean up after yourself, if you're deploying temporary development environments, and so on. Both Terraform and Palumi are open source, so you can have a look at the source code, you can download it, you can use it without any additional cost. They make all that source code available for free. There are some downsides. The obvious one is sort of the opposite of what we talked about with the cloud provider tooling, is when a new resource is released or settings changed and so on, you have to wait for the third-party provider to actually update their resources to reflect that change. It's not usually very long. Most of them have releases every couple of weeks, and you'll get a change reflected fairly quickly. But it can be slower than if you were working with a native cloud provider tooling. So if you need to get access to a resource quickly, you can do that much quicker with the cloud provider tooling. We mentioned the fact that you've got to manage and secure and back up that state file. If you want support for the tooling, so if you need help and support, you're either reliant on using some of the community stuff through GitHub issues and so on, or you need to pay for a third-party support contract with the provider. And additionally, if you want some of their more advanced features, some of the enterprise components, you are going to have to pay for those. They come at an additional cost. Both of these tools have an enterprise and a pro edition, which you pay for. But both of them do have free and open source editions that you can use without any cost. But that is something to factor in if you want to use some of those more advanced features, or if you need support from the vendor, that is going to cost you some money. Okay, so let's have a look at how that works. Sorry. So we're going to have a look at the two tools, both Terraform and Palumi. So we'll look first at our Terraform file. So we're doing exactly the same thing as we did previously. Let's close some of this. With the ARM template, we're creating a storage account. So not different really, but you can see here the language in the Terraform file is, whilst similar to an ARM template, it's a bit less verbose. So this isn't JSON. This is actually a language that is unique to Terraform. It's the HashiCorp configuration language, and it's used to declare the resources in a similar way to what we do with ARM templates. But you can just say it is a little less verbose. And what we've got here is we've got a declaration, so that we're using the Azure provider. So I mentioned these tools have lots of different providers, whereas with that ARM template, obviously we were only deploying to Azure, so we didn't need to define a provider. But with Terraform, we actually have to tell it, so we're using the Azure RM provider. Then we're creating a resource group, and this is one of the things up front that's a bit nicer than the Azure tooling, is that you can create a resource group as a native resource. You can create resource groups with ARM templates, but it's more involved because they deploy at different, what they call scopes. You have to have nested templates to deploy a resource group, which is a bit of a pain. Whereas with Terraform, we don't have to, because we can just use it as another resource. Then we've got our storage account, and you can see here that I'm actually referring to the resource group in my storage account resource to get the name from it. So not only does that allow that to flow through, but that adds me an implicit dependency here that the resource group has to be created first before the actual storage account can be created. Everything else is very similar, so we're passing in the same account tiers, the replication types, and so on. And then we've got an output here, which we didn't do before, but we had an output, so this will spit out. What I'm asking for here is the actual storage account connection string. That'll give me that at the command line when I run it. And so this is just accessing the properties of that resource using this dot notation to be able to grab me that information. So this is basically, it's doing the same thing, but it looks a bit simpler, and it uses that HCL language. So if we now go over to the command line, zoom in slightly. And I mentioned before that Terraform's got this state file, so it allows us to do a plan. So there's a command, there's a Terraform command line tool, and we can do Terraform Plan. And what this does is it takes what's in our Terraform file, and it compares it to the state file, and it works out what it actually needs to do to get the what's in the cloud to match what we're asking for. So at the moment, we don't have anything running in Azure from this file. So what it's come back is it's basically telling me it wants to create two resources, which is my resource group and my storage account. And you can see that actually, if you scroll up, it gives us a lot more information. It gives us the information about those resources as well. So if you want to check the various properties, we can have a look at some of them. So some of them it knows now, some of them it's not going to know until it's actually deployed them, so it can't tell us. So simple one, if you look at the ARM template, we've told it which location and what the name is, so it can tell us what they are. But what it can't tell us is the ID, because the ID is something that gets generated by Azure when you create it, and so it won't know that until it's deployed. And you'll see there are a few things in here that it won't know until after, quite a lot of them. So what we can then do now is we can run the Terraform apply command, and this actually deploys the resources. Now that's going to actually run a plan first, again, to tell me what it's going to do and ask if I'm happy with it. And I will have to confirm that, yes, I'm okay with that. So we'll say, yeah, we'll deploy that. And that will now go off and actually create the resources in Azure for me, and then come back and tell me that it's done. So you can see you can watch it as it actually creates the resources. We've hit the same problem that I've also obviously used the name here as well. So let's just in there. I'll do that again. So yeah, that's going to go and create those resources for me. And at the same time, it's going to add them to my state file. So it will know that, that's what I've done, so that it can then do a plan next time. And if I make some changes to that storage account, it's going to come back and tell me what the changes are. But at that point, instead of having, one or two to add, it's going to say, there's one to change, and it's going to be changing some properties or so on. So it will be able to tell me what I'm going to do, rather than just me having to make assumptions that I've written my template correctly and it's going to do exactly what I think it will. So that's creating the storage account, and the resource group should already be created. And there we go, it's finished. And you can see here it has spit out the connection string that I asked for, so I can use that to connect to the storage account. Now, the other thing I mentioned is we can do a destroy command. So again, I can run Terraform destroy. And because it knows what I created, it's going to just come up and tell me, you previously had these two things. Now you want me to delete them. And again, I need to confirm that I want that, but it's going to show me, there you go. So it's going to destroy two things. So I'll say yes, and that we'll go ahead and delete those. Now, for a couple of things, it's probably not that significant, but if you're building very complex templates or creating a lot of resources, this can be really useful. One of the most useful things I've found with this is when we're deploying things into Azure, if you're familiar with Azure, you often need to create service principals, which are basically accounts that run your applications or that run, provide you with an application identity. And you can create those, but quite often if you're using ARM templates, you can't actually create them with ARM templates. You have to go and create them manually using some PowerShell or manually in the portal. And more often than not, when people go and delete their Azure resources, they forget to delete their service principals. And you'll find in your Azure AD tenant, there are tons of expired and unused service principals because no one's cleaned them up. Whereas if I create these resources using Terraform, Terraform has a service principal object. I can create them with that. And when I'm done with my application and I run the destroy command, not only does it clean up my application, but it deletes the service principal as well. So I know I've cleaned up everything without having to remember to go and clean up that thing then in a different place that I usually forget about. So that's Terraform. The other tooling we mentioned is Palumi. So Palumi is a bit newer. It's been around for about 2 or 3 years, but Palumi it's similar in Terraform in a lot of ways in that it's doing very similar things, that it's deploying resources, it has a lot of providers and so on. But the key aspect that differentiates it is that it allows you to write your infrastructure as code in actual programming languages. So Palumi supports a few languages. So it supports TypeScript, Node, .NET languages, Python, and Go, I believe are the languages. And you can define your infrastructure using that, which has been very popular with developers, who are perhaps not wanting to learn a new language like HCL, and instead are keen to just reuse the language they already use for writing their applications to deploy the infrastructure. And that makes it a bit easier to try and get the development teams more involved in deploying these infrastructure rather than relying on IT ops teams to do it for them. And so what we've got here is the same example using Palumi, so creating a storage account, but we're using C# here to actually do that. It takes a little bit of getting used to writing sort of declarative infrastructure in a more imperative language, but it's not too bad. And you can see this is not too dissimilar from Terraform in that we're deploying a lot of we're deploying the same resources, they have the same properties, but instead of using that HCL language, I'm using C#. So if you're familiar with C#, this should make sense in terms of what we're doing here. We're using the same language constructs to create those resources. Now, if you're just declaring plain old resources like this, it's not too different. Where it has a real benefit, at least in my view, is when you're doing more complex things. So things like loops and conditions. You can do loops and conditions in Terraform. But if you've ever tried to do a for loop in Terraform, I'm sure you will understand the pain because it's not a particularly nice way of actually working. Whereas this is just C#. I can write a C# for loop just the way I would like in a normal program, and it works. The same with if statements and so on. So when you start doing more complex things, perhaps when you want to do things sort of around your infrastructure as code that aren't part of the infrastructure as code spec, having a real programming language is actually quite nice. So again, we're deploying the resource group, the storage account, we're getting the connection string out at the end of it. So pretty much identical to what we did in Terraform, but it's in C#. You could do it in Python or Go or TypeScript or whatever your language of choice is. So as with Terraform, Palumi has the concept of a state file, so we can do a plan and we can do destruction. The commands are slightly different. So instead of Terraform, you've got a Palumi command, and you can do Palumi preview rather than Terraform plan, but it's basically doing the same thing. And this will go off and talk to it. Now it's asking me here for a passphrase, and this is worth me mentioning. So when you use Terraform and you create resources, some of those resources are going to have secrets in them. They might be passwords, connection strings, those sort of things. And they get stored in the state file. And with Terraform, they get stored in the state file in plain text. And there is no way currently to be able to actually obfuscate or encrypt those files. And so you have to be very careful about where you store your state files and who has access to those state files, because those values are in there. One of the nice features of Palumi is they've taken that state file concept, but they now allow you to encrypt the data in the state file, either with a passphrase like I've done here, or using a secret provider like Azure Key Vault. you can actually have it encrypt the data in that file so that you no longer have to worry about the fact that there are secrets in it because they're all encrypted. And so that's why it's asking me for a passphrase. So this is doing the sort of similar thing that we saw with Terraform. It's going to go and compare what I'm asking for to the state, and it will tell me what it's going to do. So this is going to create those resources for me. Now I know what I'm happy with what I want there. I'm going to go ahead and do Palumi up. And that's going to do, again, same thing. It'll do a preview, and then it's going to tell me, ask me if I'm happy with it. And if I am, it will go and create those resources for me. Now you can see that it actually, the preview I got was a lot smaller than the Terraform one. It's just summarized this for me. So they've taken the sort of the view there to give you a high level view. But if I wanted to, I can go into the details here, and I can see very similar information to what's in what was in Terraform. This doesn't tend to show you those resources, those values that it doesn't know at this point. It just shows you what it currently knows. We'll go ahead and deploy that. And that will create resources in the same way as we did with Terraform. And when they're done, I have the option again to run the destroy command, which will delete those resources. So just a table here, just to quickly summarize the differences between those languages and where you might pick one over another. There are some key values here that will sort of drive what route you go down. One of the first things you'll look at is whether or not you have the need to deploy to multiple cloud providers. Because if you do, then you really need to be looking at the third-party providers of Terraform or Palumi. So that might make that choice for you. If you want the statefulness of a language, which can have a lot of benefits, then again, Terraform or Palumi. If you need to be able to get hold of resources very quickly after they're released, then you might want to stick with the cloud native tooling. And if you need the support from the cloud vendor, then again, the cloud native tooling is going to do that. There's also some additional features you can get, particularly with the third-party providers, like around governance and estate management and repositories and so on, that may make it worth your while to pay for those extra features which are not available in the cloud vendor tooling. Infrastructure as code is just code. So once we've started writing those code files, we can start making use of all the tooling that we would use with other code. So we can use common IDEs. You saw that I was using Visual Studio Code, Visual Studio. You can use the tooling you're familiar with to actually write them. You can put them in your version control repository of choice and use all the features of version controlling, pull requests, code reviews, all those sort of things. You can test those resources. So you can write some tests that actually check, that your code is actually deploying the resources you want it to, that it's configured in the right way, and so on. And you can even build CI/CD pipelines using that code to deploy and test and create resources. We'll have a quick look at how that might work. So firstly, we're going to have a look at some testing. So we've got some ARM templates here that we're deploying, and we've got some tests. So we've used the language called Pester, which is a testing language written for PowerShell, but you can use obviously any testing tooling that you would like. But this is using Pester to actually go and look at our ARM templates and run some basic tests. This first one is designed to be run before you deploy anything. And what it does, it goes and checks, firstly, that I've got the correct files, the files exist, that the files have the actual sections that the ARM template is supposed to have, and that they convert properly into JSON. If you've missed a comma or a semicolon or something, it will pick this up. It checks that I'm creating the actual resources that I expect. So these are the list of resources that should be in my template, and it will check that they exist. And it's running a pre-flight check. So you remember before we ran the ARM template and it failed because I hadn't got the storage account name right. You can actually run the tests that are run at that point using a separate command. So there's this test AZ resource group deployment command. You can run this by itself to just run those tests and not try and deploy anything. And this template will do that as well. Weirdly, though, when you run this, you actually need a resource group to exist to deploy to, even if you're not actually deploying anything. So the other part of this test, you may have seen at the beginning, I've got this before all section. We're actually creating the resource group at the beginning of the template, and then we tear it down again at the end. So these are some fairly simple tests just as a demo, but they show you that what you can do in terms of actually testing resources. So if we go ahead and run that. And this uses Pester to actually just go ahead and run tests, he says. I don't know why it's done that. Let's just recreate that session. Looks a bit better. Yeah. Log me out of Azure as well. Okay, well, in the interest of time, we will. I'll figure out why they didn't work. They did work before the call, but anyway. So what that would have given me basically was a list of the tests that did run, and it would have shown me that one of those tests had failed because I'd intentionally missed a file off. But you could run those tests, whenever you made a change to your resources. And then we had another set of tests here, which I won't go into in great detail, but these are tests that we're running after we deploy. So one of the things you're quite often going to want to do is to check that what you deployed is what you expected to be deployed. Now, to do that, you need the resources to be deployed, which is slightly a bit of a pain. But if you deploy those resources, you can then use Pester again to actually go and grab the resources and compare them to what you expect to be there and run some tests. So we're checking the network exists. There's a subnet called public subnet. It's got this IP range in it, that we've got some virtual machines, the virtual machines in the right region, and so on. We can write those tests to be as complex as you want to actually check what you're deploying is what you expect. And we can then take that a step further, and we can actually build some CI/CD pipelines to do that. So this is a CI/CD pipeline I built in Azure DevOps, but you could do it in any CI/CD tool. And this particular pipeline is a pipeline that's meant to deal with when we've changed our templates. So the assumption here is that we're going to write some templates and we want to share them with other people in our company. And so when we've written those templates and we commit them into our Git repo, it's going to run this pipeline. And this pipeline does a few things. Firstly, it runs some tests. There are 3 sets of tests. It runs this ARM TTK, which is a best practice sort of testing set. It runs the test we just tried to do and it failed, and then runs the infrastructure tests. And you can see here, actually, in between that, there's a step where I go and actually deploy the infrastructure for these tests to run. So we can do that part of our pipeline. We publish test results, and then we destroy that infrastructure that we created. Then, assuming they all pass, and if any of those fail, then we'll stop at this point and we'll get a failure result that we can dig into. But assuming all the tests pass, we then run some commands to actually zip up those files and copy them up to a storage account. So this is effectively as a sort of release pipeline for our templates so that we can get them into that storage account where they're going to be consumed by other members of our team. But before we do all that, we run some tests to make sure these pass our criteria for release before we can get to those. We have another pipeline in here, which is more of a release pipeline. This is going to deploy our infrastructure into our environments. So this is not talking about the templates themselves, but actually creating resources with those templates. And so we've got 2 environments, and this is using the YAML pipeline, which is a bit harder to read, but we've got 2 environments. We've got a development environment and we've got a production environment. And each of those environments, we're having it run that resource, the ARM template, but we're passing in a different parameter file. So we've got a dev parameter file, and we've got a production parameter file. And so if we run that, you see here we've got those two stages, so with development and production. So development has to happen first, and we've then got an approval step here that when it deploys to development, somebody has to come in and actually approve they want to move the deployment into production. So there's a gate there for us to do that. And again, you could build those pipelines to be as complicated as you want. You can have as many environments, different approvals, build some tests in there as well if you wanted to. But again, it's all just code, so you can use these code-based tools to deploy your infrastructure. So just to wrap up, we've got a couple of minutes left. So if you want to get started with infrastructure as code, the easiest thing to do is actually to try it out. There's only so much you can learn from me talking to you or watching videos or anything. The best thing is to actually try out the tooling and see what works for you. And if you're looking to pick a particular tool, try out what looks interesting. If you're interested in Terraform, Palumi, ARM templates, whatever, try them out, see if they work for you, and get started with a small piece of work. So take yourself a project. You want to be able to deploy a storage account, a web app, or whatever. But yeah, pick a small unit of work to be able to get familiar with it, and then once you're happy and you're familiar with it, you can iterate over that and you can add more resources. A key point is when you're learning, don't do it in production. Don't try and take your production environment and move it to infrastructure as code straight away. You're going to make mistakes. You're going to end up iterating over your template probably more times than you want to before you get it right. So make sure you do it in a development environment. And one other piece of advice I give you is to try and keep your templates focused. The temptation is to try and build a template that will deploy every single piece of your application in one go. And whilst you can do that, it's not always the best idea, because when you come to make a change or you want to adjust one little bit of your application, you've now got to rerun the whole template. And if you make a mistake, it could take out your entire application. So try and sort of what they call lower the blast area, make your template specific to the life cycle of things. So things that are on a similar life cycle probably live together. Keep them small and focused so that you can just deploy those, the particular bits you're interested in. Store your code and version control. If that's your first step into doing any sort of development-based approach, look at version control as the first route into that. It's easy to do and it gives you a lot of benefits, particularly when sharing and working across teams. And when you're ready, have a look at doing more advanced things like testing and CI/CD and so on. And that's it. So I think there was a question in this. I'll just look at that. But if you've got any other questions, I'm happy to answer them. So it says, what IAC tools are you looking at for the near future? Where do you think things are heading with IAC? So there's a few. I work with quite a few tools. I guess one of the things that I am doing quite a lot more work in Palumi at the moment. I'm working with quite a lot of development teams, and so being able to write stuff in C# has been very beneficial, and I've enjoyed working with that tool. I'm also doing some work with, I mentioned Bicep, which is the sort of successor to ARM templates that sits on top of ARM templates and allows you to write code that looks a bit more like Terraform. Those are the two areas. There seems to be a lot of movement in the infrastructure as code being real code stuff at the moment. So Palumi being one of them. Terraform have recently released some abilities to write some of their stuff in actual code. It's only certain things. I think it's mainly around AWS. Obviously, AWS has got the CloudFormation stuff you can do in code as well. So there does seem to be a movement in that area to writing, actual code using TypeScript. This seems to be quite a popular one. But yeah, that seems to be where things are going at the minute. If anyone's got any more questions, I've got a few minutes.
Yeah, we'll wait for some questions. Thanks a lot, Sam. This is great. Yeah, I enjoyed it. Palumi, it escaped me. I'm going to have to go check that out.
Yeah, it's fairly new. It's been around for a few years, but it's only the last year it's got some traction. But yeah, I've really enjoyed working with it.
Now, I want to thank David Cobb. He's actually set this meeting up with you. And he's actually one of our board members for the Microsoft South Florida Cloud Group as well. So
that's great.
Here's another question.
Any news regarding the Azure SDK management libraries? They're in beta for a month. I don't know, unfortunately, the answer to that one. My answer to that one is it's not something I have been that involved with. So I can't answer that one, I'm afraid. Jenkins or Ansible, what would you suggest? They're different tools, and I've not worked with either of them that much. But obviously, Jenkins is more of a CI/CD tool, whereas Ansible is more of your configuration as code tool. Well, yeah, configuration management as code tool, although it is moving into more areas, which I guess you could do some more CI/CD stuff in Ansible as well. So it depends what you're trying to do. If you're looking for a pure CI/CD play, then Jenkins is probably where you would go with that. Whereas if you're looking for more of a hybrid with you want to do configuration management, and you can even use Ansible to do your infrastructure as code deployments for cloud providers as well. But it's not as developed as your pure your pure infrastructure as code pieces, and some of the ways you have to do it are a little bit janky, but yeah, it depends what you want to use it for. But yeah.
All right, any more questions? Anybody?
Yeah, so there's one here from David about Farmer. Yeah, so Farmer's I'm aware of. I haven't tried it, but Farmer's very similar to Bicep. In that it wasn't written by Microsoft. It was done by an MVP, I think. But it's an abstraction on top of ARM templates. So it does the same sort of thing as Bicep, where you write your actual template in a different language, and then it sort of compiles them into an ARM template. So what you're actually running when you deploy it is still an ARM template, but you're not using the JSON language. And so it'll be interesting to see what happens, because obviously Bicep and Farmer are quite similar and do a similar thing. And obviously Microsoft are working on Bicep, but they, having spoken to, I do quite a lot work with the ARM team at Microsoft, and they are very open to having other approaches to doing it and supportive of that. So yeah, it's an interesting one. I haven't really used it, but I'm aware of it.
All right, I think that's about it.
Great.
Last call for questions. All right. Well, thanks again, Sam. That's
problem.
Great. And see everybody soon. I'm going to end the broadcast now. Thanks.
Thanks, everyone.